a $160 mini PC run a Homelab? I pushed one to a limit to see if it can, and here's what happened. This tiny PC costs less than $160 and it fits in the palm of your hand. On top of that, it barely uses any power, but today I'm actually going to be pushing it to the limit, to a breaking point, just to see what kind of power or performance I can get out of this mini PC. I want to know if a budget mini PC like this can actually run a Homelab, not just one or two services or a website, but a real-world use case. For example, using WireGuard for VPN remote access, running Docker containers to experiment new and cool technologies, and running Jellyfin for media streaming, and even doing some development work, whereas putting a website and a PostgreSQL database. Now, most people would think that you need to spend upwards of $500 or more to create a Homelab, but I say let's see what happens when we throw everything at this $160 box and see what happens. This isn't a synthetic benchmark test. This is a full hands-on stress test on the cheapest Homelab setup that you can find currently. In this video, we're gonna take this mini PC and install an operating system on it and load it with services just to see if this thing survives. Spoiler alert, it gets heated at the end, but not in the way you think. Before we dive in, why even build a Homelab in the first place? A Homelab is like a personal playground. I personally use my Homelab to learn new things that range from running Docker containers, mainly for checking out new and cool technologies, and creating virtual machines for experimenting specifically with AI models and more. And not only that, I run services that allow me to remote into my home network. I also run a NAS system which stores terabytes worth of videos and documents for me. But if you're someone that's just getting started, think of it this way. It's just something that you can use to tinker around, learn new things, and see what's under the hood just to, get acquainted with new sorts of technologies. To give you an example, I had to test something before I applied changes in a production environment. So I used my Homelab to confirm that change and make sure that it works 100%. Had anything gone wrong during that change, I would have caught it ahead of time before dealing with consequences or headaches in the actual production environment. The best part is that everything is running locally in your home. No need for cloud subscription models. You have complete privacy because everything is staying locally on your home network. All right, let's talk about hardware. You don't need to buy this exact mini PC that I have. Just go to Amazon and type 16 GB Intel 150 mini PC. The mini PCs can range anywhere from $140 to $200. And the key thing here is that Intel N150 chip and that 16 gigabytes of RAM and that 500 gigabytes of storage. Now, if you want to talk specifics, for my use case, I'm using the Beelink S13 Mini. This runs about $160 and it's got those specs that I mentioned earlier. So far, I've had this since November of 2024 and it's been working every single day without any issues. So I think Beelink is a very good choice for this. And just to cover the technical aspects, this mini PC is an Intel quad-core processor, meaning it has 4 cores, 16 gigabytes of DDR4 RAM running at 32 megahertz, and it's got 500 gigabytes of NVMe SSD. It does have an additional slot that you can, use to install another NVMe SSD, but do note that that slot runs at X1 speed, so it's going to be not as fast as the main slot. And the best part about this mini PC is that it's quiet and it draws less than 10 watts of power most of the time. So you can run this 24/7 without worrying about a big electricity bill. Now, I did make some upgrades along the way, and these upgrades are not technically needed, but those are optional. Now, this mini PC comes with 2 M.2 slots for storage. So I went ahead and installed 1 terabyte of storage in each slot. So that's an upgrade from 500 gigabytes to 1 terabyte. So for the first slot, it's going to install the main operating system. And then the second slot will be there for storage purposes only. Do keep in mind that the second slot is slower, working at PCIe X1 speeds. Now, it also comes with 16 gigabytes of RAM, which is decent for light workloads, but I'm upgrading it to 32 gigabytes of storage so that I have more headroom in case I decide to spin up more virtual machines down the road. Now, for the OS, this is where most budget Homelabbers start. You can simply go and install a Linux operating system like Ubuntu, Debian, or really any kind, but I'm going to be installing Proxmox. Proxmox, in simple words, allows you to run multiple operating systems on one PC. So imagine if you wanted to run, Windows 10 and an Ubuntu operating system. Without Proxmox, you would have to buy 2 mini PCs. So with Proxmox, it allows you to share resources within the same machine. And basically, you can install multiple operating systems on one machine as long as you have enough RAM and CPU power. In technical terms, this is called a hypervisor. Now, installing Proxmox is quite simple. All you got to do is head over to the Proxmox website and download the latest free version of Proxmox ISO. All right, so the first thing we're going to do is make a bootable flash drive so that we can plug this into our mini PC and install Proxmox. So the first thing I'm going to do is go ahead and download Proxmox ISO. So to do that, just Google Proxmox ISO, and then the very first link, go there. And then the current version is 8.4. Next up, let's Google Balena Etcher. And then same thing, depending on your operating system. If you have Windows, download the Windows version. In my case, I have a MacBook Pro, so I'm going to download the Mac version. And once it's installed, open up Balena Etcher and then choose Flash From File. And that's going to be our ISO. So in this case, Proxmox 8.4. Next up is the target. So I'm going to select on the target. And in this case, I am going to choose my SanDisk USB drive. Hit select and then hit flash. Depending on your specifications, it may take anywhere from a couple of seconds to a couple of minutes to flash the USB drive. All right, next up, I'm going to go ahead and plug in my mini PC and then get it powered on. And then I'm going to connect my USB drive for installing Proxmox on it. All right, so the very first thing we're going to do as soon as we boot on this PC is keep pressing the delete button until the BIOS screen pops up. Once that happens, I'm going to go into the boot section and then choose what device I want to boot from. So by default, I'm going to boot from my USB drive and make it my number 1 option. So I'm going to go ahead and do that, save and exit, and the device is going to reboot. And now we're at the Proxmox install page. From here, I'm going to choose the very first option. And once we're there, the very first thing we're going to do is accept the license agreement. Next, we're going to choose what drive we want to install Proxmox on. So in this case, I'm just going to use the first drive. So in this case, I have 2 NVMe SSDs. So I'm going to choose the first one and then click on next. Choose the country, choose the time zone. In my case, I am America, Chicago. And then that should be it. The keyboard layout and all that's fine. Now it's time to set up our super secure password. All right, so automatically, if you have your LAN cable plugged in, it's gonna detect your network and put all the settings in for you. In my case, I did that and it's automatically there. Next, I'm gonna hit next and confirm if everything looks good, which in this case it does, and then hit install. The installation may take anywhere from a couple of minutes, should be less than 5 minutes in total. All right, once the installation is done, it's going to reboot. And right before we do that, it's going to provide us with the URL that we can access our Proxmox. So remember to unplug your USB drive because otherwise it will boot you right into the installer. All right, once Proxmox has been successfully installed, you should be getting a login page like this. Now, you don't have to do anything here. Just note down the web address. So in your browser, go to that URL address. So I'm going to do 10.0.0.110 port 8006. That's what it is in my case. and I should be brought to a login screen. So I'm going to go ahead and log in. All right. Once you're logged in, just ignore all the messages. Let's verify what we are working with. So I'm going to click on PVE. That's our Proxmox instance. And then click on the summary page. From there, we can see that I have 4 CPUs. Mostly are at idle at about 0%. I have 32 gigabytes of RAM. Remember that I upgraded my RAM from 16 to 32. And to verify our storage, we're going to go down and click on disks. And in here, I have 1 terabyte of NVMe SSD. That's where Proxmox has been installed. And I have additional NVMe storage, which is about another terabyte. And that's for future use or any extra storage that I want to use in the later. All right, now let's get to work. Now that we have our Proxmox installed, next thing is to set up an Ubuntu server virtual machine. Ubuntu is a lightweight, reliable operating system that makes it super easy to install and manage services. One key example is, installing Docker and running Docker containers. Linux is the best place to do that. Now, I know you might be thinking, why not just use LXC containers instead of Docker, because they work directly with Proxmox? And that's a fair question, but in my experience, LXC containers tend to be a hit or a miss sometimes. Many are outdated, and the ones that I need no longer are being actively maintained. That's why I prefer spinning up a virtual machine, installing Ubuntu, and inside of that, installing Docker. Yes, it's kind of an extra layer, kind of like an onion, but in return, you get stability, flexibility, and access to the latest and greatest features along with Docker with proper support. Now, before we can create the virtual machines, the very first thing we need to do is download the ISOs for Ubuntu and Windows. So let's go ahead and download the ISOs. So Windows 10 ISO download, let's just Google that. And then go to the Microsoft website. And from here, select your version. So in this case, Windows 10 multi-edition. It's going to do its thing. And then choose your language. In this case, English United States, and hit next or continue. All right. And then what we want is the 64-bit version if you have the Beelink S13. So instead of downloading it, what I'm going to do is right click and copy link address. And then go back to my Proxmox. And then in here, what I'm going to do is go down to local PVE. And then in here, I'm going to click on ISO images and then click on download from URL, paste my URL, and then hit query. And then now detected it and hit download. So now instead of downloading this and putting it on my machine and then uploading it, it's going to directly go and skip 2 steps and make things faster. So while that's going on, I'm going to do the same thing on Ubuntu. So just Google Ubuntu server and hit get Ubuntu server. And then from here, it's going to start the download process. And what I want to do is hit cancel because I don't want to do that. And then just right click on download now, copy link address, go back to Proxmox, and then click on download from URL, paste my link, query the URL, and hit download. So now we have both Windows and Ubuntu ISOs being downloaded at the same time. We're going to use this to create our virtual machines down the road. And just to show you, here are our 2 ISOs that are available. So let's go ahead and create our Linux virtual machine. All right, so to do this, we're going to click on Create VM or Virtual Machine and give it a name. So in my case, it's going to be Ubuntu. And then we're going to click on the next tab and select our OS. So in this case, we're going to choose Ubuntu. And everything else is fine. Then go to System. Graphics card default is fine. Everything else looks fine. Hit Next. For the disks, we're going to leave everything as is, and I'm going to give it about 80 gigabytes of storage. So if you got 1 terabyte, feel free to adjust this however you want. For my use case, I'm only going to put 80 gigabytes. Hit Next. For the CPU, I have 4 cores, and in this case, I want to use all 4 cores. So I'm going to go ahead and hit 4. And for the type, now this is important. I always choose host because that unlocks my CPU directly onto my virtual machine. So I'm going to do host and hit next. Now I have 32 gigabytes of memory. In this case, I'm going to give it 8 gigabytes. So that equates to 8192 megabytes is about 8 gigabytes. For network, we don't have to do anything. Leave everything as is. And then hit finish. All right. So our virtual machine should be ready. Now I'm going to hit start. And to see what's going on in there, I'm going to click on console. All right, so the first option we are going to choose is try or install Ubuntu server. Now that we are at the setup screen, I'm going to choose my language, which is English. And then hit done. And I want to do Ubuntu server, so I'm going to hit done there as well. It's going to automatically assign the IP address. At this point, note that down because that will come in handy. All right, so next, hit next or done. The proxy address, we don't have to do anything there. It says the mirror is being tested, so let it do its thing. And you can skip it right about now once it starts fetching the list. Okay, now here you can use the entire disk. And I recommend, or in my personal use case, I always uncheck the LVM group. And we're going to go down to done and hit done. And then hit done again. Says, are you sure you want to continue? Because this is not reversible. So I'm going to hit continue because I'm confident this will work. Now you have to fill out the information. So again, take a note of this because you only get to do this one time. Confirm your password and then hit done. So before we continue, let me write all that. All right, we'll hit done. Skip that step for now. We don't need Ubuntu Pro. Do want to install OpenSSH server because that allows us to remote in. So we'll go ahead and do that and hit done. And then again, hit done here. And that's it. The install will continue and the system should reboot and you should be brought into Linux. Now that we have Ubuntu installed, we can now install Docker inside of Ubuntu virtual machine. Now, if you're new to all this, you might be wondering what exactly is a Docker. Think of it as a way of running applications in a lightweight and isolated environment called containers. Unlike a full virtual machine that runs its own complete operating system, a Docker container includes the bare minimum requirements, just the app and the libraries it needs to run. Nothing more, no desktop interfaces, no unnecessary background services. Just the essentials needed to get from point A to point B. Installing Docker can be a little intimidating at first. There are a few terminal commands and system tweaks that are involved, but don't stress out. I have linked a step-by-step guide below that walks you through with everything. And if you follow it carefully, you should have no problem installing Docker onto your Linux environment. Once Docker was ready, that's where the real fun began. I started spinning up Docker containers, and the first one that I did spin up is called WireGuard. Now, the WireGuard instantly turns my S13 Mini into my own private VPN server. I can securely tunnel into my home network from literally anywhere, whether if I'm at a coffee shop, at a hotel, or through my phone 5G internet, I can quickly connect into my home network and access files, documents, or whatever I need from my home lab. Now, for installing Docker containers, I prefer using a .yaml file. This allows me to provide all the instructions and configuration that I need to get my Docker containers up and running very smoothly. To give you an example, here's how I do it. So this is what the Docker compose file looks like. It's got all the instructions, got the database, username, password, all that, all the configurations that are needed to spin up the Docker container properly. I'll show you how to spin up Gitea using Docker Compose. So I Googled Gitea and then I go down and this is the Docker Compose for a simple setup. So we can go ahead and copy that and then go to our terminal and then let's go ahead and create a new folder. So these are all the different folders or services that I currently have. So I'll make a new folder for Gitea. So I'll say mkdir git t and hit enter. And if I do ls, which lists all your directories, we can now see that we do have git t right there. So we're going to go into that folder by doing cd git t. And then in here, I'm going to create a new Docker Compose file. So I'll do nano docker-compose.yml. That's the YAML extension. Hit enter. And then in here, I'm going to paste the code that I copied from the git t's instruction site. So to start from the top, these are all the instructions that it's going to have. And then towards the bottom, I can change the port number. So I don't want to use 3000 because that's already in use. So I'll do like 3200 and then save by doing Control S and then Control X for exiting. So if I do ls, I can see my Docker Compose has been saved. And now to spin that up, I'll do Docker Compose up -d. And then it's going to do its magic and spin up our Docker container. All right, so we are at our git t configuration page. So you can see how simple and easy it is to, set that up. Next up, I switched gears and went into development mode. I launched a Postgres Docker container connected to my Django app, which is mainly for managing my YouTube content, which I made myself, by the way. To my surprise, it ran beautifully with fast response and no lags at all, no crashes or anything like that. And to tie it all together, I installed Gitea, basically a self-hosted version of GitHub. Now, I know you might be thinking, why would you use Gitea instead of GitHub? Well, the simple answer is privacy. You see, my code can stay local and version controlled in my Homelab environment without getting pushed into the ether. That's pretty wild, right? For $160, a mini PC can run a VPN, a full stack database, a full stack app, and host my private code all in my Homelab environment. Now, if I did something similar on the cloud environment, I'll be paying a monthly recurring fee for sure. So that's why you can see why the Homelab starts making sense all of a sudden. All right, let's push this thing even harder. I wanted to see if the Beelink S13 Mini could handle media streaming. For this, I'll be installing a Microsoft Windows 10 operating system. Here's what I have. So I gave it around 12 gigabytes of RAM or memory. I gave it 4 CPUs, and I gave it about 40 gigabytes of space. Now I can use my ISO that I installed earlier and then set up the Windows 10. So I won't bore you with this. It's a very lengthy process. This video might go into an hour plus. So we'll keep it simple and then just Google or find a video on YouTube on how to install Windows. And it's a very simple and straightforward process. Now, I do have a separate NAS or a network attached storage system. So that's why I'm giving it 40 gigabytes of storage. But if you wanted to host your files onto the NAS system, give it more space so that, you have enough room to stream and place your media files. Once Windows 10 was installed, I headed over to the Jellyfin's website to download and install the Jellyfin server. It's very simple and straightforward. Now, what is Jellyfin? It's a free open source media server, kind of like Plex Media Server, but without the bloat or the subscription. I have been using this for over 2 years now, and it works very nicely. So once it was installed, I loaded up some 1080p videos and some 4K files and hit play. And immediately I could hear the CPU go 100% and the fan kick on. So the CPU usage went up to 100% and the playback was, let's just say, ambitious. In the beginning, there was some buffering, but then no hiccups once the video got started. And this was true for both 1080p and 4K. So right now, Jellyfin is relying solely on the Intel N150 CPU for transcoding, which, as you can imagine, isn't ideal. I'm still trying to figure out how to get the hardware acceleration working through the integrated Intel GPU. So if you have any tips on how to enable iGPU support for transcoding on the Intel N150, drop some links or feedback in the comments below. I would love to hear if you got yours working. Now, if you're sitting there thinking, okay, cool, You have a VPN, you have Docker, you have even Jellyfin running. But what else can a mini PC like this do in a home lab environment? Well, you'll be surprised how far you can stretch this thing. Once Docker is up and running, you open the door to an entire universe of self-hosted applications. Here are some of the famous Docker containers you can easily deploy onto this mini PC. First up is Glance. Glance is a slick home lab dashboard to keep all your tabs and services all in one page. Next up is Portainer, which is a web-based UI to manage Docker containers without the need of a terminal. Ad blocker can really block those annoying ads, and a lot of people use it for, setting it up with their DNS to block some websites and unwanted ads. I think that's the number one reason why most people go build a home lab in the first place. Now you have Vault Warden, which is a self-hosted password manager. It's all contained on your local home lab. There's also Homebox, which is basically can track all of your equipment inventory, your PCs, serial numbers, phones, and whatnot. But that's just a scratch of the surface. The possibilities are endless. Apart from that, if you already have a home lab, this mini PC can be turned into a backup for your main home lab. So what you can do is take snapshots or backups every single day, just because if your main home lab goes down or anything happens, you have your backups ready and can quickly come back online. This mini PC also makes for a fantastic automation services. You can run N8N, or in my case, Apache Airflow, to automate tasks like pulling down my YouTube stats. I use Airflow to hit the YouTube API, which allows me to download all of my YouTube data, including views, revenues, comments, and subscriber counts. Basically, I can get all of my analytics downloaded and then run some of my own custom analytics and dashboards. Not only that, you can schedule some basic Python scripts or cron jobs to send alerts or, update something. Realistically, the possibilities are endless. Well, that's it for this video. I hope you really enjoyed it. Let me know in the comments below if you have any questions or concerns. Let them know in the comments below and I'll sure try to answer them. And just to give you an update on the Minis Forum MSA2 video, I'm still trying to figure out how to pass through the NVIDIA graphics card into my Proxmox, so stay tuned for that. So far, I haven't had good luck, passing it through. So when I do that, I will make a video. So I'll see you in the next one and take care.